they've gone all in on DevOps. They've read about it, they've studied it, they've gone to classes on DevOps. They 100% believe this is the way going forward. And in the last session, getting started with DevOps, Tailwind traders, they've even decided on their tooling stack. So now they're ready to start DevOpsing. But what exactly is DevOps? You ask 10 different people, you're going to get 20 different responses. At Tailwind Traders, they decided to adopt Microsoft's definition of DevOps. DevOps is the union of people, process, and products to enable the continuous delivery of value to our end users. Now notice, I said this very carefully because every word has meaning. Now notice I didn't say continuously deliver code, because what will that give us? Piles and piles of code sitting on some server somewhere. This does no one any good. And notice I didn't even say continuously deliver features, because I could be delivering feature after feature, sprint after sprint. But if this is not what my end users need or want, why am I wasting my time doing it? So the key here is we need to continuously deliver value. It is 100% vital that Tailwind Traders continuously delivers value. But why is this so important? Here's the thing. If you haven't adopted DevOps best practices, your competition, they either have or they will. And when they do, they will out-innovate you. And when that happens, it's game over. You will quickly become obsolete. And none of us wants to be obsolete. Now, this isn't just DevOps theory. We've been doing this long enough now that we have empirical proof. Organizations that adopt DevOps best practices absolutely out-innovate teams that don't. And not just by a little bit, but by a lot. And this is why Tailwind Traders needs to adopt DevOps best practices. But it's not easy to do right. In order to really adopt DevOps best practices, you have to address all three of these pillars: the people, the process, and the products. Now, people, that's a cultural change that has to occur within your organization, where every person from the very, very top all the way down to the bottom must be hyper-focused and aligned on continuously delivering value. For the process, we need a process that will let us iterate fast enough, yet still deliver code of high enough quality. Now, finally, we need products that can help enable all of this. And at Tailwind Traders, they've got the people and the culture down, right? Everyone has been trained, everyone is aligned and believes in DevOps, everyone is prepared to do whatever it takes to continuously deliver value. They've even got their products and tools down, as you saw in the first session. So all they need to do is just figure out their process. Now, in order to continuously deliver value, they need a process that is highly iterative, yet still delivers code of high enough quality. And it needs to be highly iterative because they want to have many frequent small releases versus infrequent large releases. This way, they can continuously deliver value. Now, with many small iterations, they also have the ability to course correct really quickly. Now, we don't always know if what we're doing is what the end users really wants or needs. So if we have a lot of small iterations, we can now make a hypothesis, spend, let's say, 2 weeks implementing it, release it to the public, gather telemetry to see if end users really value this new feature. And if they do, hooray for that. We can double down on features like this or even expand upon this feature. And if they don't, not a big deal, because we've only wasted 2 weeks versus months and months and months of dev time. We will just reprioritize the backlog and then rinse and repeat this process. So what kind of a process will let us do this? Agile and the many flavors of Agile. So things like Scrum, Kanban, Agile with a capital A. Now, personally, I'm a massive fan of Scrum. I love Scrum. I'm a Scrum purist, and I've led several successful dev teams using the Scrum methodology. And I'm not saying any of the other flavors of Agile aren't good, because they're all good, they work. But today, we're going to be looking at Scrum. In Scrum, everything starts with your backlog. And what's a backlog? Think of it as a prioritized wish list of everything you want your software to do. So the most important things are at the top, and the least important things sink to the bottom. Now, at the beginning of a sprint or an iteration, the product owner will go ahead and prioritize that backlog. And then the team will commit to doing part of that backlog based on the priority and what they think they can get done. And then they'll spend the sprint working, they'll burn down whatever bugs are found in sprint, And at the end of the sprint, they'll show what they've accomplished to the product owner in a sprint review meeting, and hopefully they'll push into production as well. And based on the sprint review demo, the product owner then will reprioritize that backlog, and this whole cycle can rinse and repeat itself. So that was a super quick description of Scrum. So let's dive in a little bit deeper and look at some general principles. First of all, this is not a waterfall project. We don't build the entire thing and then release it. We build it up incrementally, so sprint after sprint, building the highest priority items on the backlog first. And we do this because this allows the product owner to look at what we're building at the end of every sprint. And when they do, they can now give immediate feedback. So this here is vital. Most of the time, people don't really know what they want their software to do until they start clicking on the buttons. Because you notice how people are super quick to tell us what they didn't like versus what they want their software to do. So by building our software incrementally, we can now have frequent inspections of our software and immediately course correct as needed. So instead of wasting months of work, the worst that could happen is we waste one iteration and then we course correct. So super powerful, super useful. All right, next in Agile or Scrum, everything should be transparent. The dev team, they're not working in a vacuum. The product and sprint backlogs should be public, where everyone can easily see what the team is currently working on and what the team will most likely work on next. Transparency and communication, again, is another key part in Agile and in a DevOps world. Next, I wanted to touch on what makes up a Scrum team, because there's only 3 roles. First, there's the product owner. There's literally one job for the product owner to do, and that is to prioritize the backlog. The first thing I tell a new product owner is that this is not a waterfall project. Again, we don't ship when everything is finished. In fact, most likely, we won't ever get to a point where everything on the backlog is finished. So hopefully we'll be shipping at the end of every sprint. So we need to make sure that the most important features are prioritized so they get done first. Prioritization, and then the course correction that comes from reprioritizations, that right there, again, another key concept inside of Scrum. Now, in order to be able to prioritize correctly, the product owner has to be able to make decisions on how that product will function and what it will look like. Or said another way, the product owner has to have a vested interest in the end result of this piece of software. The success or failure of this piece of software must directly affect the product owner. Next, there's the Scrum Master. Now, the Scrum Master has 2 roles. First is to make sure the team follows Scrum best practices. And second is to protect the team, the Scrum team, from outside interference. You ever get that high-level exec that walks up to a dev directly and tells them, I need you to add this feature immediately, right? And of course, this messes up everything from the planning to the scheduling, so on and so forth. It's the job of the Scrum Master to protect their team from people like the high-level exec. They need to be able to tell them, nope, you don't get to do that. You can't drop something on us mid-sprint. Put it on the backlog, you can rank it really high, and we can tackle it next sprint. Finally, there's a dev team. This team, it needs to be cross-functional. When there's someone on your team, you need to have people on your team that can do whatever, whenever that needs to be done for the project. And the more cross-functional your team is, the better it is. Now, I know in an ideal world, every person on the team can pick up any work on the backlog and just get it done. In reality, most people are not 100% full stack, right? But you just need to make sure there are team members that can cover tasks, the different types of tasks. However, we do strive to be cross-functional. So sure, we do each have our own areas of specialty, but don't let that stop us from grabbing tasks, learning, and growing. Let me give you an example. I was once on a project where I finished up all my tasks, and I'm a back-end dev. The only remaining work in the backlog was some crazy SQL query. Now, I do know SQL, but I'm really kind of good enough at it to be really dangerous, right? That's the level that I'm at. So yes, I did pick up that task, but I also pinged my teammate, who is an expert at SQL, and I asked them to pair with me. Because now they can make sure I'm not doing anything crazy or wrong, and I can also learn from them. This will help me ramp me up. It will upskill me on my SQL skills. All right. Finally, these Scrum teams, they should be self-organizing. No one needs to direct a Scrum team on how to do the work. what they need to do, so on and so forth. They can figure that type of stuff out for themselves. All right, writing software, it is like a three-legged stool. You can have quality, you can have a date you are done, and you can have features. And guess what? You can only move two of those things, right? And in a software project, quality is not negotiable. You cannot skimp on quality. So what that means is if you want more features, you must move the delivery date out. And if you can't move the delivery date, you're going to have to reprioritize the features that you're going to ship with. It is that simple, and there are no exceptions to this. Also, when you're planning, estimates, they're not guarantees. And although the more you do it, the better you do get at it. So estimates, they've always been a bit fuzzy, but to help with your estimates, here are my rules. I want to break down all of my work into 4-hour chunks. Why 4 hours? First of all, it's a lot more accurate. I'm pretty good at estimating things within 4 hours. I'm pretty good at estimating even a day's worth of work. 2 days of work? Yeah. More than 2? All right, more than 2, I'm starting to guess. Now, my go-to estimate, if you ask me how long it will take to do something, I'm always going to say 2 weeks. Why 2 weeks? Because I think I can write just about anything in 2 weeks. I can probably write an entire OS in 2 weeks. But to be really accurate, I'm only good to about a day or two. And I've been doing this for over 20 years. All right, so next, if we break down a user story into 4-hour chunks, there's now a possibility that instead of just one person spending 3 days working on this, this can be split up into a lot of small tasks, and my team can work on it in parallel, which means we can potentially knock this user story out much faster. Also, with much finer grained tasks, it is so much easier to track progress. So if I just have a task that's 2 weeks long, when I look at my board, how do I know work is progressing, right? Because we've all done this, where on day 1, we can say, hey, we're 20% done. And after day 2, we can say, hey, now we're 60% done. And then on day 3, we're at 90% done. And for the rest of the 2 weeks, it just stays at 90% done. And at the end of the sprint, we're still not done. So if you break down your task into 4-hour chunks, this lets us plan and track work so much better. And finally, never start from a date, right? Because developers, we're pleasers. We want to make people happy. So if you start from a date, we're going to magically subdivide the work up so they'll fit in the allotted time. Even though this doesn't work and it's not accurate, it's kind of what we do. So don't start from a date. Work out the task, break it down into 4-hour chunks, and then see where the end date lands. Finally, the rules apply to everyone. In order for Agile to work, everyone in the organization must be hyper-focused and aligned. So remember, the whole point of us moving away from Waterfall to Agile is we finally admitted that Waterfall does not work well for software projects. In fact, 90% of Waterfall software projects flat out fail. And by fail, I mean they go over budget, over time, too many bugs, or the end result is not what the end users want. So we know the old metrics and the way of doing things is garbage. We must all be aligned now with how things are done and measured in an Agile world. Everyone from the very, very top all the way down to the bottom. And no one is exempt from the rules, no matter what their title is. Okay, so Tailwind traders, they get Agile. They get Scrum. But to do Scrum right, they need tools that will help them track their work from sprint to sprint to sprint. They need to be able to easily reprioritize work on the backlog, as well as track their work both within a sprint and across sprints. And all of this needs to be easily accessible by everyone, because remember, no one is working in a vacuum, right? The product backlog, the sprint backlog, the current product plan, those need to be publicly available. And guess what? Azure Boards, linked to my GitHub repo, does a great job of this. So let's check this out. In the world of Agile or Scrum, everything starts from the backlog. So here's my backlog, and as you can see, it's an ordered list of everything that I want my software to do. Adding new work, I can just click the new work button, I can give it a title, add to the top, and there it is. Now, if I click on this particular work item, it opens up a form and I can give more details. So I can give things like descriptions, acceptance criteria, etc., etc. Now, if I want to prioritize my backlog, that's as simple as just dragging and dropping on this board. Now, the other thing people use the backlog for is they choose the work from the backlog and say, this is what I want to do for a particular sprint. So they create a sprint backlog. In creating, that's easy enough. I can just go ahead and multi-select, and then I can just drag it and drop it to the sprint that I want. And if I click on the sprint, it will take me to my sprint backlog. Now my sprint backlog behaves exactly the way I expect it should. You can now prioritize work by dragging and dropping. I can add new work as well. And the other thing it can do is I can break down my work into the individual tasks that I need to complete this item. So again, tasks, remember, they should be 4-hour chunks, right? So for this particular work item, let's say I need to update my database schema over here. And I also, let's break this down a little bit more. Let's say I need to update my API layer. Awesome. So pretty cool, right? Now I have my work item. I've broken it down into 2 individual tasks. I love backlogs, both the product backlog and the sprint backlog. They're great at adding and prioritizing work and doing breakdowns. But where they start falling down is tracking work as it's happening. Now I want to be able to track my work as it happens, and I want to be able to do this visually, both within my sprint and across sprints. And you can totally do this with Azure boards. So the first thing that we're going to check out is the task board. So here it is. Here you can track what your team is doing within a sprint in a visual manner. You can drag it and drop it, and you can see what's going on. Super, super cool. Now, if we zoom back out a little bit, we can see at a higher level what a team is doing from the Kanban board. So this is a fully customizable Kanban board that shows the ongoing state of my project. And I really love this board because now in one place, I can easily see what's going on in my project. I can also see when a work gets stalled in a particular column. And when I notice that, I can now redirect my team. We can swarm on that particular unit of work. There's also deep integration between the work items created in Azure boards and also with GitHub. So let's go check out this deep integration between the 2 systems. So let's bring up GitHub. And if I make some changes to my file, all I need to do is format my commit message in a certain way. So let's pretend I'm doing work for work item number, how about work item number 425, all right? So in my commit message, I just need to say, let's say doing some stuff, this is where the magic happens, fixes AB pound 425. Now, check out what happens when I click the commit buttons. Look at the board and bam, did you see that? How cool is that, right? The work item magically flew over to the done column because of that deep integration with GitHub. But wait, there's even more than just that. Let's take a look at this work item. This work item is now linked to the specific commit in GitHub. If we click on this, it's a deep link into GitHub that will take us directly to our comment or our commit. And now we can see exactly what we did in the GitHub UI. Super, super cool. This deep integration between Azure boards and GitHub makes working really, really nice. Okay, Tailwind traders, they're now almost ready to start diving into code, but they still have one process question, which is what branching scheme do they want to use? Now, traditional branching schemes involves a lot of long-living branches. So you've got dev branches, QA branches, feature branches, UAT, main, et cetera, et cetera. And having all these long-living branches, it's not conducive to moving quickly. Like anytime you need to merge code from one long-term branch to another, boom, a merge bomb goes off. And guess what? Sooner or later, you're going to get a code conflict. And fixing these merge conflicts is not easy or pleasant or quick to do, right? This is extremely painful and an expensive problem that everyone will run into if they use long-running branches. So to solve this problem, Tailwind traders, they've decided to use trunk-based development, where they're basically deving and releasing right off the main branch. So the way they do this is when a dev picks up a user story, they create a topic branch, do their initial work, and they very quickly merge that topic branch back into the main branch. With no long-running branches, there's almost no merge bombs. And any conflicts that do exist, they can be solved really, really quickly. So easy peasy, right? Problem solved. But some of you might be thinking, how can this possibly work, right? If you're practically deving off the main branch, how are they not just introducing bugs all over the place. They solve that problem by using a software technique called feature flags, or feature toggles or switches. So feature flags is a technique that lets you turn on or off certain portions of your code during runtime. In one deployment, you can now ship alternate code paths, and during runtime, you can pick which path you want to go. So this is awesome because what that means is you've now separated deployment of your code from the delivery of your new features. So this starts making things super, super flexible. Because of that, every new feature and every new bug fix Tailwind Traders writes, it must be wrapped in one of these flags. So now they can check into master without fear. As long as a flag is off, the new code does not get run, only the old code. All right, from a code perspective, there really isn't anything magic with feature flags. They're glorified if statements. Wait, actually check that. They're not glorified if statements. They are literally if statements. They really are super easy to implement. So I've come across a lot of companies, when I tell them about feature flags, they'll be like, oh, feature flags, it looks really cool, right? But we're not ready to use feature flags. Our application isn't architected in a way to support feature flags. That's just ludicrous, because if your architecture supports an if statement, guess what? Your app, it's ready to use feature flags. And once you start using feature flags, you can now start doing some really cool advanced DevOps stuff. For instance, you can do things like A/B testing, where a percentage of your traffic runs in variation A and a percentage of your traffic runs in variation B. And now you can grab the telemetry and figure out which one is delivering more value, right? Very powerful. You can also use feature flags to do something called safe deployment, where you only turn on the flag for a really small percentage of your traffic, and you make sure everything still looks good and works for just that small percentage of your traffic. And then you can open up your flag a little bit more and make sure that works, and open it a little bit more until you're very sure everything is good, and then you can turn it on for your entire traffic. Finally, another thing you can do with feature flags that's super cool is if something goes wrong with your latest deployment, rollbacks become super easy. All you got to do is just turn off your flag and voila, you're done. The new feature, that's what rolling out is. That's all it takes. All right, so enough talking about feature flags. Let's see them in action. So what you're looking at is my resource group in Azure that holds the resources for this particular project. And one of the resources is going to be an app configuration, right? So this will hold all the configuration for my application, including my feature flags. So to look at my flags, we'll go to feature management, and notice I have one feature flag right now, and it's called the new about flag, and it's currently in the off position. So if we jump to my application and we refresh this, okay, here it is. Look at across the top, there's an About tab, and it just says About. If I click into it, that's my current About page. Hooray for that. All right, let's jump back to the portal, and we're going to turn on our particular flag. So here's our portal. We'll turn on the flag. That's all it takes. Now let's jump back to the application, and we'll refresh. And now check out the About. Instead of About, it now says New About. And if we click it, it takes us to the new About page. Pretty cool, right? All right, so as you can see, these feature toggles, really easy enough to toggle it on and off while you're live, while your website is running. So you can also do this programmatically as well, turning the flags on and off using the CLI. Now to implement, super easy to do as well. So let me show you. Here's my code. You can implement your flags both in the view and also the code. So let's check out the view first. This right here is your standard .NET view. You can add a feature flag by adding this tag, the feature tag, with the name of your feature, and with negate is equal to true right here. What that means is if the flag is off, then go ahead and output this chunk of HTML. Otherwise, if the flag is on, the new About flag is on, output this chunk of HTML. So what this is saying is if the flag is off, just output About, and if the flag is on, you output the new About, right? That's what we saw. All right, so in my code, this is how you would implement it in code. So I'm using .NET, and these flags are supported in a bunch of different languages. You can do this in two ways. First is by adding this annotation to an action in your controller. So if the flag is on, this action, it will exist. And if the flag is off, this action, it won't even exist. You can also do this inline with the if statement. So here I can say if, and I use a feature manager object, if it's enabled, and I pass in the feature flag that I'm checking, and if that flag is enabled, go ahead and run this chunk of code inside the if statement. And if the flag is off, you do the else, right? All right, so to see this running, let's set a breakpoint, and we'll go back to the app, and we'll go ahead and trigger this. So let's jump to the home page, click on New About, and it will hit our breakpoint. Hooray for that. And now, when we walk over this if statement is going to evaluate, and you'll see that the flag is on, so it goes into the if statement and runs this chunk of code. Now, when we jump into the view, this is my About view. And if the feature is on, it's going to go ahead and output this chunk of code. And if the feature is off, like negate is equal to true, right, it's going to output this chunk of HTML. And if the feature is on, it's going to output this chunk of HTML. So, feature flags, they're super powerful and they're super easy to implement, both in your code and also up in Azure as well. All right, finally, Tailwind traders, they've got one thing that they're worried about, and that's quality. So moving as quickly as they will be moving, they're not going to have time to do full end-to-end functional testing. So they need to shift left and build quality into their app as they're writing it versus trying to tack on quality at the end, like the way traditional software is QA'd. So one of the things they did to improve quality is they're requiring every check-in to go through a pull request or a code review. However, they quickly ran into some problems with their pull request workflow. First, pull requests were getting lost in the shuffle. People would either miss or ignore pull requests, and they would start piling up. Now, there are some amazing benefits with pull requests, but if you don't do them immediately and they start piling up like this, your dev work comes to a grinding stop. Now, another problem they had when reviewing the code changes in a PR is that they really wanted to see the changes running in a live test system. But that's a lot of work, because what that meant is for each PR, they'd have to build the app, package it up, provision the infrastructure they needed, configure it correctly, then they needed to deploy the app into the freshly provisioned infrastructure. And now they can finally see those changes. And oh, when they were done with the PR, they really kind of need to clean up the staging environment too, right? Because otherwise they're just going to leave a giant mess. And that sounds pretty crazy. Like being able to do this for each PR, it would be awesome. But really trying to execute this would be a serious pain. I mean, who has the time or energy to be able to do this correctly every single time and to do it quickly? And that's where GitHub Actions comes to the rescue. So Actions, that's GitHub's workflow engine, where you can automate all sorts of things inside of GitHub. Just as an example, I created automation using Actions to help take care of Tailwind traders' pull request problems. So to solve the problem of PRs stacking up with no one really knowing PRs are there or waiting for them, what I did was I created a swim lane in our Kanban board, and I called this pull requests. And now whenever there's a pull request, I'll have GitHub Actions automatically create a pull request work item, link it to the GitHub pull request, and I'll put it into the Kanban board into the correct swim lane and the column, right? So this way, it is readily apparent there are PRs waiting to be looked at, and if no one picks it up quickly, as the Scrum Master, I can jump down my team's throat until someone finally does it. But wait, there's more, right? Next, I'll have this action automatically build and package up my application. And then, since I'm using Azure App Service to host my app, I'll dynamically create a staging slot named after my pull request ID, where I then deploy my application. And then, since the URL to my staging slot is dynamic and changes for each PR, I use Actions to write back to my pull request with a link to my staging environment for this specific PR. So this makes it super convenient for the person reviewing the pull request. And finally, when the PR is closed, I'll be a good citizen and my action will go up, clean up, and delete the slot from Azure App Service. So this sounds kind of nuts, right? But we can totally do it. Let's check it out. So what you're looking at right now is all the resources for this specific application up in Azure. One of the resources is the app service hosting this application. So if we go ahead and look at the deployment slots for this specific application, we'll be able to see that I have one slot right now specifically for production. All right, let's jump into the Kanban board. And you can see that it's configured exactly the way Tailwind traders want. So they have an emergency swim lane for live site incidences. So again, this way it's super easy for them to see. The team can swarm on live site incidences and they can fix it. It's very visual, front and center. They also have a swim lane specifically for pull requests. So again, they were having trouble seeing when pull requests happen, and pull requests were getting lost in the shuffle. So this way, it's really easy to see. It's on their board, front and center. Team members can see it and jump on and start doing their PR. The rest of the board is configured exactly the way Tailwind Traders wants it. And okay, so let's go ahead and create a pull request, and we'll make some code changes. So let's pretend this work that we're doing is for work item number 432. And instead of checking in directly, we'll create a branch. And then we'll go ahead and create a pull request. And as soon as I create that pull request, it's going to go off and kick off that automation that I have. So let's jump into the Actions tab, and we'll see the automation happen in real time. So here we are, automation's been kicked off, and now we can see in parallel, we're creating a new pull request work item inside of Azure Boards, putting it in the right place. Bam, did you see it? There it is. And we're also going to, in parallel, build my application, right? So when it's done building, it will then provision a new slot in my app service, and then it will deploy that newly built app into the provision slot. So this takes a little bit of time to do. So while this is running, let me show you how I configured all of this. Now, the automation is using GitHub Actions. And the way you set that up is off of your root directory, you're going to have a .github/workflows directory. And here's where you store the definitions of your workflows. And you're going to store it as YAML files. And I know nobody really loves YAML, but this one's pretty easy to understand. So first, you're going to name your workflow. So it's called name. And next is the on section. That's going to be your triggers. So I have two triggers. One of them is for pull requests. So anytime somebody issues a pull request to the master branch for open, synchronize, reopened, or close, it will go ahead and trigger this specific workflow. There's also another trigger called workflow dispatch, and this is just a manual trigger that I trigger from the UI. So I can use this to help me debug this workflow. The next section is my jobs, right? So the first job that I have is let's go ahead and create my pull request work item inside of Azure Boards. So that's what it does. Next, in parallel, I build my application. So I restore my packages from NuGet, I build my app, package everything up, I upload that package as a zip file back up to GitHub. Hooray for that, right? It's just a normal build. And now for my deploy stage, this is not going to run in parallel, right? Because I need to wait for the build to actually finish. So right here where it says needs build, that's where I'm saying wait until the build is finished, then go ahead and do your tasks. So what is this one doing? It's going to download my build artifacts. Then it's going to go ahead and get my pull request values from GitHub. So things like the title and the ID. And then I'm going to use the Azure CLI. So first I log into the Azure CLI. And then using the Azure CLI, I can create a deployment slot that's based off of the pull request ID. And when that's done, I can deploy my app into that specific slot. And when that's done, that's when I can go and create a comment into my pull request. So that's what I'm doing here. I create a comment back into the pull request into GitHub, and I give it the unique URL to the dynamically created slot. All right, and when I finally close this pull request, it's going to go ahead and clean everything up by deleting the correct slot. So it does that by getting my pull request values, then using the Azure CLI, I go ahead and delete what I need. All right, so let's go back to my actions, and we can see that it looks like it's completed. Everything is green, that's good. So now let's jump back to the browser. And we'll go ahead and check out what really happened in our environment. All right, so first let's go back to the portal, and we can see, let's refresh this, and bam, there's a new staging slot with the ID of the pull request. All right, so now if we go back to our Kanban board, we'll be able to see that it's created a new work item, right? And if we click on this, this will take us into the work item. And this is super cool because you can see that there's a link, there's a deep link back into GitHub. So this links us back to the GitHub pull request where now you can see it's adding a brand new comment. So we can click on it and we'll see, dun dun dun, we added a new comment that says created staging environment with a URL to my staging environment. So this makes it really easy for whoever is doing my PR. Now, if I click on this link, bam, it takes me to my app running in my staging environment just like that. How cool is that? All right, so not only does it do all of this, it does clean up, right? So if I go ahead and close this particular pull request, let's check out what should happen. It should clean up my staging environment, right? But again, automation is going to kick off, so we'll jump into actions. And you can see there it did. Automation is kicked off. And if we drill into it, we can see that it's now closing my pull request and cleaning up my staging slot. And it does that by deleting the correct staging slot from my Azure App Service. Again, this takes a little bit of time to do, so we'll go ahead and wait until it's done. All right, it's done. So now if we go back to the Azure portal, let's refresh this, and voila, the staging slot has now been cleaned up. Very, very cool stuff. Okay, so what I wanted to demonstrate with this specific demo is that I wanted to show that we can create a very intricate and complex workflow using GitHub Actions. And because Actions is so flexible, you really can make these workflows do just about anything, not just CI/CD. So go ahead, go and create automations to help enable your workflows. So this is super cool, man. Tailwind traders, they're now in a really good state. They have adopted the DevOps mindset. They've picked the products that will help enable DevOps, and they've implemented processes that will be doing what they need to do, right? So they've got everything now. They have the culture, the people, they have the process, and they have the tooling. So now the fundamentals, they are all in place, and they're now ready for some more advanced topics. So join us in our next session, Delivering Change in the Cloud, and we're going to dive into ways Tailwind traders can deploy into the cloud both faster yet safer. So we covered a lot today, so let's do a quick recap. At a high level, we covered how Tailwind traders will be running their projects using Agile and the Scrum methodologies. And Tailwind traders, they're going to be using trunk-based development with feature flags to be able to move at DevOps speed. And finally, using GitHub Actions as an automation engine, they've automated a fairly complex pull request workflow to help them move quicker yet safer. Now, if you would like to take a deeper look into all these DevOps concepts and more, head over to aka.ms/allthingsdevops, where you're going to find our DevOps Resource Center. Also, to get certified with AZ400 certification, head on over to aka.ms/AZ400cert. And to prep for the exam and to learn all the DevOps techniques in AZ400, head on over to aka.ms/gettingstarteddevops. And finally, to learn all things Microsoft, head on over to microsoft.com/learn. All right, thank you all so much, and I'll see you in the next session.